All right, so lesson 4.4, periodic functions, stretching, shrinking, and translating graphs. There's a lot of information in this one section alone, so don't hesitate to re-watch this video several times before each piece makes sense to you. Okay, periodic function. A function is periodic if there's a positive number p, a period of f, such that this statement is true. Okay, whole lot of words for us that get you to understand. A period is how long it takes for a function to repeat the exact same graph. So the period, notice it's how long I start from my maximum here and I get back to that exact same maximum. So over here, the period, here's a maximum until I get to that maximum. Now I don't have to go max to max. I can think of it as, okay, I'm to the left here. How long would it take me to get to that exact same spot on the next graph? And that's how I could measure a period. Okay, on the first one, if I went from valley, that minimum, to that minimum there. Okay, those lengths, those distances are still exactly the same. We're just going from one defining part on the graph to the next of the exact same defining piece of information about the graph. Okay, so periodic functions, p is the length of one cycle. How long does it take for a function to repeat the exact same graph? Okay, so if a period is 2 pi, every 2 pi units is the same length. So from 0 to 2 pi, there's one period. If the period is 4, it takes 4 units. So if I start at -3, 1, 2, 3, and I end at 0, that's 4 units. I better be at the, nope, that's only 3 units to 1. I better be at the exact same spot. So here at -3, when I trace that period of 4 units, there I am at that middle of the little maximum there, that local maximum. Period of 6. Okay, 1, 2, 3, 4, 5, 6. Is this the exact same cycle if I go any 6 units? Okay, or if I start at -4. 1, 2, 3, 4, 5, 6 units. So I go so at -4, I'm at the top of that graph, and then where do I end after 6 units? At that exact same spot, that top of that constant function there. Now, we'll study periodic functions a lot more when we get into trig functions, so it's important that you're understanding it's just how long it takes for the function, the cycle, to repeat itself. Okay, so more words here, okay? What does this mean? If I have a function value, if I'm at 0, and let's say the period of the function is 2, then that means every multiple of that period, those y values are going to equal. Okay, they're going to be equal to each other. So if I start at 0 and the length of a period is 2 units, then f of 2 has to equal f of 0, and then f of 4 has to equal f of 0. That's what this means. Okay, p is my period, so x plus the period is going to equal whatever that original value of f of x is. Okay, well then it's going to equal any multiple of the period. Okay, so this is f of 0 is f of 0 plus 2 times the period. Okay, so these multiples are important when we go to actually attempt to look at a graph and use that information to find another y value, like here. Okay, so determine the fundamental period. So I'm going to go max to max. 1, 2, 3, 4, 5, 6, 7, 8. Takes 8 units for me to get to the exact same spot on the graph. Okay, to find what these values are, we're going to go back to like what we did with I, and I know this was challenging for most of you, but I repeated itself every 4. We had I to the first, I squared was equal to -1, I cubed was equal to I to the 4th was equal to +1. So when we simplified something higher than an exponent of 4, we took the exponent, divided it by 4, because that's how long it took to repeat, and we said this goes in 10 times with a remainder of 1. That very important remainder is exactly how we were able to simplify I to the 41st power. It became I to the 41st was equivalent to I to the first power, and I to the first power was just simply I. So we're going to use that same information of a remainder. But now our period's going to change. Our divisor's going to change depending on our given function. So if I want to determine what f of 24 is, I'm going to take my x value divided by the period. I get 3 with a remainder of 0. That value of the remainder is the equivalent x value. So f of 24 is going to be equivalent to f of 0. And again, why was it f of 0? Because that's what my remainder was when I took the x value and divided it by the period. So now when I look on the graph, f of 0 is equal to 0. That's the corresponding y value. Okay, so for 99, I take my x value divided by the period. That goes in 12 times. 12 times 8 is 96 with a remainder of 3. So f of 99 is going to equal f of 3. Okay, well 3 is in the domain of what's graphed here. So 1, 2, 3. When x is equal to 3, my y value is positive 1. Okay, so this value of the remainder is very important. And again, we saw it already, so it's not brand new, but it's certainly something we'll have to work on. Okay, the amplitude is the height of a function. Maximum, largest y value, and minimum would be the smallest y value. Okay, so my amplitude, the height of my function, is my largest y value is at 2. My smallest y value is at negative 2. Max minus min, all divided by 2. That gives me 4 over 2. So the amplitude, the height of my function, is 2. Okay, so try this one for homework. Period, amplitude, and then use the remainder to find f of 45 and f of 75. All right, stretching and shrinking. Now I know your notes are all in black and white, but I would suggest using a highlighter, colored pencil, pens, and put this information in here according to the colors. A vertical stretch. So vertical, right? Vertical is our y-axis. So we're talking about how our y values are affected here. The number is the multiplier out front of the function. If that multiplier is bigger than 1, we're stretching the graph vertically. That's what we have in blue there. If the multiplier is between 0 and 1, then we're shrinking the graph vertically, and that's what's graphed in blue in green. Okay, so the period, now check out what's happening. I'll go from the original in red, and this is one that we already looked at. Period 1, 2, 3, 4, 5, 6, 7, 8. Period is 8. When I look at 2 times f of x, 1, 2, 3, 4, 5, 6, 7. Notice that my period, and the notes are here, it's the exact same for any vertical stretch or shrink. Because if we're stretching or shrinking it on the y-axis, I'm not affecting my x values at all. And it's the x values that determine the period of the function. So no matter what the value of c is, my period, how long it takes for a cycle to repeat itself, is always going to be the same. Now your amplitude, your height, is what's going to be affected now. So my amplitude for f of x, my original, 2 minus negative 2 gives me 4. 4 divided by 2 is 2. Okay, now up here I have a y value of 4. And there's my lowest y value of negative 4. 4 minus negative 4 is 8. 8 divided by 2 is 4. Now in green, to find my amplitude, my highest y value on green is 1. My lowest y value on green is negative 1. 1 minus negative 1 gives me 2. 2 divided by 2 is 1. Well, notice how these are related to the original. If my original amplitude is 2, 2 times 2 gives me my amplitude of 4. 2 times a half gives me my amplitude of 1. So the amplitude on a vertical stretch or shrink is just that multiplier, that C times the original amplitude. Okay, do these for homework. Sketch it. Sketch each. Determine the period and amplitude for each. Okay, now a horizontal stretch or shrink. So my horizontal axis, now we're going to affect our x values here. So notice our multipliers on the inside of the parentheses because it's affecting our x values. Okay, so this one is a little bit counterintuitive. If my multiplier is bigger than 1 inside the parentheses, it's actually going to be a horizontal shrink. So it's going to condense it horizontally, okay, on the x-axis. If my multiplier is a fraction between 0 and 1, it's actually going to make it a wider graph horizontally. So again, please get a colored pencil, highlighter, whatever, and make sure you're matching. Notice that the blue is the shrink to the blue graph on the original. Okay. So now the period, how long it takes for the graph to repeat, is obviously going to have to be affected if I'm stretching or shrinking horizontally. So in red, same period. Period is 8. That's been the graph we've been using. Now my period for 2 times x, that's my graph in blue. So I'll start here. 1, 2, 3. That period is 4. Notice the period got smaller when I performed a horizontal shrink. Now for the 1/2 x in green, I'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can't even determine the period from what's given on the graph. So here's your relationship for the period of a horizontal stretch or shrink. So when your multiplier is on the inside with the x, the period is P divided by C, whatever your multiplier is. So my fundamental period before I stretch it was 8. When I divide 8 by a half, remember dividing by a half is multiplying by 2. So the period for the stretched out one is actually 16 units long. Okay, so that's why we can't see it from the graph that's given. Okay, now notice here my amplitude, if I'm moving my x values, not my y values, my amplitude isn't affected at all. So the amplitude, the max minus the min, stays the same if only a horizontal stretch or shrink was performed. Okay, and there are your notes in there. The amplitude is the same. Oh, we got to fix this. The amplitude for f of c times x is the same as y equals f of x. Okay, so last problems for homework. Sketch the graph, determine the period and the amplitude for each. Okay, and translations, which I think are the easiest, which we've already done, we will be able to fill those in class. So have those 3 homework problems completed for next class.